In this video, let us look into some of the useful results based on circles. It's not circle, but circles. That is, so we've got one of the results here which states this. If two circles touch internally, then the distance between their centers is equal to the difference of their radii. So what does that mean? It's pretty straightforward. So let me just, show you with the help of a diagram. So say we've got two circles, all right? So say this is one circle. And say we've got another circle which touch internally, okay, which is like, say, smaller than this, something like this, all right? So, and say what it says is then the distance between their centers is equal to the difference of their radii. That's what it says. So say the center of this bigger circle is somewhere here, and then the center of the smaller circle is, somewhere here, right? So now what is the distance between these two centers? The distance between these two centers is nothing but the difference of their radii. Say for example, if the smaller circle's radii is 3 centimeter and the bigger circle's radii is 5 centimeter, then the distance between their centers is 5 minus 3, which is 2 centimeters. So that's what it says. It's pretty easy. So if you come across this kind of a diagram, in which two circles touch internally, then if you want to know the distance between the centers, all you have to do is find out the radii and subtract them, and then you'll get the distance between the centers. So let's look into another result. Here we are with another result which reads like this. If two circles touch externally, well, here we did some internal stuff, here it's external touching, then what happens? Then the distance between their centers is equal to the sum of their radii. Now this is a much simpler result than this one because pretty evident from what it reads itself. So, let's say we've got one circle like this, right? And then say we've got another circle somewhere here like this. It need not be of the same size, it can be of any size. So what is the, the distance between their centers? Say the center of the blue circle is green and the center of the green circle is this blue dot. Now what is the distance between these centers? Isn't it pretty, evident from what you see that if this is the radius of this blue circle and if this is the radius of this green circle, then adding these two would give you the distance between their centers. So that's all this is. So if two circles touch externally, then the distance between their centers is equal to the sum of the radii. All right, so let's go to the next result. Let's see what it is. So here we are with another result which says distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. So say for example, if you've got a cycle and say you've got a bigger cycle and a smaller cycle, and then say you ride your smaller cycle and then say you just complete one revolution in your small cycle and one revolution in a bigger cycle, which cycle would have taken you more far? Definitely the bigger one, because what it says is distance moved by a rotating wheel in one revolution is equal to the circumference of the wheel. If your smaller cycle had a circumference, say if the wheel of the smaller cycle had the circumference, say 30 centimeters, then you would have moved only 30 centimeters in one revolution. If your bigger cycle had the wheel of your bigger cycle had a circumference of say 100 centimeters, then you would have moved a distance of 100 centimeters in just one revolution of the bigger cycle wheel. So that is what this is all about. So if you need to find out what is the distance moved by a rotating wheel in one revolution, all you have to know is the radius of the wheel and use that data to find the circumference of the wheel, and the circumference of the wheel is going to be the distance that the rotating wheel moved in one revolution. So that's what this result is all about. Not much to draw for this, so I'll go to the next result. So here we've got another result which states that the number of revolutions completed by a rotating wheel in 1 minute is nothing but the distance moved in 1 minute divided by the circumference of the wheel. Say for example, you've got a cycle and you drive around for a minute, all right? So if you need to find out the number of revolutions that your wheel would have made, then what you need to do is you just have to find out the distance that you moved in the 1 minute. How much did you drive around? And then know the radius of the wheel, by which you find the circumference, and then substitute in this fraction, and then there you have the number of revolutions that your cycle wheel would have completed in 1 minute. All right, so this concludes this video of useful results based on circles. So in the forthcoming videos, I'll see you with problems based on all the concepts that we've done in the videos till now.